the injector here regulates the pressure of the tank is very high, it's 350 or 700 bars, to around 2 bars also to inject, to supply the hydrogen at 2 bars. And in this way, both hydrogen and air are at the same pressure. That is very, very important, because if not, we can break the stack. And this an element, this element, which is a differential pressure sensor, and continuously measure both pressure. If there is a high difference in pressure between the hydrogen and the air, can stop the fuel cell system in order to not to break the stack. It's very important to control the pressure very well. And continuing the hydrogen in the outlet, it is also it have also a lot of water, because the stack I have mentioned it before, produce a lot of water to the air and also to the hydrogen outlet. And here there is a valve, several valves. One of these control the water and to the outlet. And another important component is this one. It's a electric pump that recirculates the hydrogen, because the outlet of the hydrogen is normally closed. This electro valve closes the hydrogen in order to make possible that all the hydrogen reacts, and in this way the efficiency in the consumption of hydrogen is very high. So the hydrogen, not consumed hydrogen, is recirculated continuously until almost 100% of the hydrogen is consumed in the reaction. That is not necessary in the air, because the air is cheap, the air is free, but the hydrogen is very, the price is very high. It's expensive. So, and the range, the autonomy of the vehicle depend of the hydrogen stored, but also depends on how much you can consume. So with this recirculation circuit, you can consume almost 100% of the hydrogen. That is why this recirculation pump is necessary. But in order not to inject again the water and flood and produce the flooding of the stack, the water is separated and derived to the outlet. It's mixed with the air, and this is the exhaust pipe of the vehicle. And that is the hydrogen circuit, how it works. Some question?
How it is separated water from the hydrogen?
Here there are, I don't know how to say in English. It's a water-cooled solenoid valve. It's a special valve that can separate.
Yeah, because the hydrogen is in the high part and the
Yes.
low part.
Yes. I think that mainly works with gravity, and then the water is separated in this way. Okay, and the third circuit is the cooling circuit. This is a standard circuit is not special in the fuel cell system. And has a electric pump in order to circulate the water, and 3 valves, three-way motorized valve in order to control the temperature of the water. When you start the system, normally the stack is very cold, so the 3-way valve, the same that in an internal combustion engine, derivates all the water in this internal circuit, and when the stack is heated and it's at the temperature of the normal temperature of function, around 70 to 80 degrees, then the 3-way valve supply the water to the radiator in order to cool down the water. It's very, very similar to the cooling circuit of a combustion engine. And finally, as we mentioned before, the stack produces power, but the power is produced not in the constant voltage. It's a function of the current. If you supply a lot of current, the voltage of the stack is lower, and if you supply a small current, the voltage is very high. So, but at the end, the electrical engine needs a constant voltage. So there is this component is power DC-DC converter, which function is which every voltage that is in the inlet, this component supply the voltage to the electric engine at a fixed voltage. No? For example, there are several standards. At the beginning, the electric cars works at 400 voltage, but in the new models, the standard voltage in the electric cars are 600 volts or even 800 volts. And I think that in high power trucks and high power trains and ships, the voltage is even higher, you know? And this component makes this function. Whichever the voltage is delivered from the stack, this DC-DC converter deliver the voltage at a constant voltage, which is normally the voltage of the battery pack. All the fuel cell system needs a small battery packs in order to start up all the system, like internal combustion engine needs also a small battery to start all the system. In the fuel cell system, it is necessary also a small battery, and the voltage of the battery must be the same voltage at the outlet of this DC-DC converter. And finally, the last circuit, but maybe the most important, you can see here a lot of components, valves, electric valves, compressor, pumps, the sensor of pressure, sensor of temperature. There are a lot of components that must be fine controlled in order to make the stack works perfectly. So this, all of these components must be controlled with a specific unit control in fuel cell systems. We call it fuel cell control system, FCCU, that control of these components and also communicate with the central unit of the vehicle, which is the engine control unit, ECU of the vehicle. So the ECU of the vehicle is also communicated with the fuel cell control unit. This component is very important to make all these components work together correctly. Some questions? Okay. This is an schematic drawing of how works a cell inside the fuel cell stack. This is the chemical and physical origin of how the electricity is generated. Inside the fuel cell stack, there are many cells, maybe 200, 300, or even 400 cells stacked in series because each of the cells produce only 1 volt. So it is necessary 200, 300, 400 cells to produce higher volt in series. And in each cell, there is the same structure. There is an anode side, a cathode side, and electrolyte. The anode side is a catalytic structure with platinum that contains platinum and makes the hydrogen split in proton and electrons at very low temperature, at 70 degrees. The catalytic material of the anode side transform the hydrogen in protons and electrons. The electrons are drawn in an external electrical circuit that produce light or power to the engine, or whichever do you want to do with this electrical current, which is an electrical flow of electrons. But the protons go through the electrolyte, which is a very, very thin membrane, and reach the cathode side. This membrane is very important because it allows the flow of protons, but this membrane is not electrically conductive, so the electrons cannot go through the membrane. This is the base of the technology of the fuel cell. This technology is known as PEM, proton exchange membrane fuel cell. And this is the center of the technology, a membrane that permits the flow of protons, but not the electrons. And in this way, the electrons are forced to go to the electrical circuit, external electrical circuit, and the protons pass through the membrane to the cathode side. In the cathode side, there is also a electrolytic a catalytic material, based also in platinum. And in this cathode, the reaction is more complex. Is the reaction in this side when you split the hydrogen in protons and electrons is called hydrogen oxidation. In chemical reaction, and oxidation is when you separate electrons from a substance. In cathode side, the reaction is